Good morning, good afternoon, good evening, everybody, wherever you are in the world. Thank you for taking time out to be with us today. My name is Steve Robinson. I am one of the business development guys here at Galarath Incorporated. I am based in the UK with my colleague Keith Garland, who is also on the call. Keith is our resident technical expert of all things SEER, and he's here today to provide you guys with an introduction to a new capability within the suite that we have created, which brings design to cost or rather brings costing into the hands of the designers, because design to cost is becoming more prevalent and more necessary. In this instance, with our SEER 3D tool, which utilizes step files from any CAD system, it links in with the main SEER for manufacturing estimation engine. SEER 3D has a number of capabilities for machined components, sheet metal components, additive manufacturing, and today we're going to be looking at composite components. We're going to provide a high-level view of the capabilities of SEER 3D, what it can be used for, what it can do, and why. We are going to touch on a number of areas, but literally touch on a number of areas of capability. If you would like more details, there will be more detailed presentations within the schedule of what we're producing to allow our customers and prospects alike to understand the capabilities before them. So without further ado, I will hand over to Keith to go through this capability and provide you with this introduction. Keith, it's over to you.
Thank you, Steve. Hello. So good morning, good afternoon to everybody. Today, like Steve said, we're going to be looking at SEER 3D. So in front of you, you are looking at the SEER 3D interface, the GUI, and it's the same interface whether we're doing sheet metal, machining, additive, or composites. All you do is you import a part from the Import tab, you go off, search your directories, find a component, bring it in, and click on OK. It brings it in, takes us to the general setting, and this is where we can select between machining, additive manufacture, composites, and sheet metal. So from here, this is where we make our choices, and today we're looking at composites. The model works with something we call environments. Now, environments are templates of information that you can control, critique, that reflects your process rules, your process capabilities, the specifics to your manufacturing that you wish to embed within SEER, within SEER 3D, so that you can reflect the nuances of your production, that you are in a good position to get a accurate, should cost very quickly, that's going to be repeatable using SEER 3D. So the environments themselves, these are just the basic ones, and you can add your own. So we're going to make this little C section using hand layout. We can do AFP, we can do layout with core, toe placement, etc. So how many are we going to make? We're going to make 100 of them. And are we going to hot panel form press it? We could do, we could say so, but we're not going to do it. This chosen C section, which I guess looking at the geometry, it's a C. Its shape complexity has been calculated by the rules based upon the number of geometry, shapes and sizes and different things that are in the rules that you can edit. So it counts things like features and corners and things, and you can decide whether this is going to make it complex or not. So the bounding box, you can control the bounding box, go back to the original, or you can define your bounding box if you want to change the orientation for ply laying purposes. It's calculated the overall dimensions of the part, the thickness, the length, the width, and here we have our part volume, part weight, surface finish area based upon the information that we've told it so far. So we come to the next tab. So the material, we can then choose from the list of available materials that reside in SEER. All things that, if you know about SEER from manufacturing, we give you a starting list of materials, and you can change that, and you can add your own materials. We don't know what you buy, how much you buy, so we give you that ability to add your own materials at your own buying powers into the model. So I'm just going to put in something in the middle here. What shall I apply? We're going to have, we'll go for this one. And it's calculated that needs 8 plies of 100% volumes or drop off. So we could say we're going to have more of these, so we can make this come back. What's it doing? And we can update it using this one. And you can see the volume is splitting between the drop-offs. So as I come up or down, you'll see the drop-off number increases. So this is making sure that the volume remains constant. So we're going to have 8 full plies, 9 drop-off plies that are covering 50% of the area. So that's covering these runners here. We can add additional plies if we wish to. So we can come in here, we can add a pearl ply, we got one of them, add another ply. So we can put in a core, a noodle, metallic skin if we wanted to. We'll add one of them. And then we come here and we look at the equipment. So how are we going to cut this? So we look at this, we can choose between the electric gerber knife, hand cutting, ultrasonic cutting, or water jet. So we're going to say we'll use the ultrasonic. How are we going to locate the plies? So we can use it by inkjet, template, or laser. I'll use a template. How are we going to debulk it? So I'm just going to use just a nylon bag, and we're going to debulk it every 4 plies to start with. No hot debulking. We're going to cure it in an autoclave, and these here represent the cycle time for the curing. If there's any resins, if you're doing RTM, that would appear here, but it's grayed out. We're going to trim it. Yes, we are. Any additional items? We haven't got a core. We will do NDT. We'll turn on tool fab design, and we'll leave finish and heat treatment on. And again, these are controlled by our rules and environments. Now, in the environment, you will have an Excel workbook. You will have an MFG file with all of the processes in that get saved as individual knowledge bases for use with this one bespoke environment. In there, this is where you decide what heat treatment you wish to have for this part. Are we going to sand it? Are we going to clean it? Are we going to spray it? Are we going to paint it? And you can decide that within the heat treatment rules. Likewise, in tool fab design, you control the tooling list that you think you will be necessary to manufacture this part family. And like I say, you can build environments for part families, for product lines, for competitors, whatever you wish it to do to aid procurement, for should cost estimation, challenging your supply base, getting value for money, or it could be to maximize your profit to get some good costs in for your employers. So that's the final tab here, and we're ready to go. So the process options are completed, and we come to the estimate button, and I'll click on estimate, and now it's taking all of our rules. It's opening SEER for manufacturing. It's inserting work elements to do the composite operation, the curing, the trimming, the finish and heat treatment, and also provide us with a tooling list in this case. And here we go. So a quick introduction to SEER for manufacturing. So SEER for manufacturing is the 2D costing solution from Galraith. It has been around a long time. It's very process rich. There's lots of features and functions which will allow you to do estimates from traditional bottoms up drawings. You don't need a 3D model. You can put in many different processes. Today we're looking at composite, but if I insert a work element and just show you. I click on that one, and you can see from the list, there's machining, sheet metal fabrication, electrical assemblies, which are cables, harnesses, fiber optics, assembly, which is welding, brazing, riveting and staking, mechanical assemblies, moldings, castings, forgings, powder metal, isostatic presses, injection molding, thermoform molding. There's a lot of different ones in there as well. We can do PCBs, PCBAs, and all of the detailed processes associated with the manufacturing of electric boards. Finish and heat treatments, or process steps, whether it be plating, whether it be treatments, whether it be sanding, scuffing, chop peening, all those sorts of processes are tucked away inside of there. Composites, we have the aero operations. These were developed by the partners of the Joint Strike Fighter, the F-35 Lightning. So we have fit up, fasten and drill, which are for like aircraft assemblies. We have composite operations, a lot of composites, braiding, powder preform processes, hand layup, toe placement, and others to complement SEER and its composite capability. And this is the process that it's using in our 3D solution with the Aero Cure, the Aero Trim. It's doing non-destructive testing. It does E-beam assembly, 3D reinforcement, aero sheet metal, superplastic forming, diffusion bonding, purchase parts, additional items, more composites, tube weld fabrication of pipes, hydraulics, fuel pipes, etc., and additive manufacture. So as you can see, we cover a wide range of processes, but today we're focusing on composites. So our 4-pane configuration, we have our work elements here, and for every work element, we have a corresponding set of parameters. We have a general tab, which is common across all the processes, where we talk about the production quantity, the batch size, labor rate, classification of the parts, capabilities of the people, quantities. You can put step learning in. We can work in multiple currencies. You can do wraps and fees, and so on. So we have this set up by the environments for us. So this captures our commercials for what we're trying to achieve. The process specific, so from our estimate, it's brought in, it's selected hand layup as a process, which is what we selected with the environment. It's brought in the geometric sizes, the length, the width, the area. It's selected the skin and fuselages, its part family, and we're doing cutting, labeling, and kitting. This is the ply table it's provided. So if I click on one, you'll see. So it's put in 2 full plies. This is the roll width. This is the cost of the material. Is a full ply. That's the material we selected. We're doing ultrasonics. We're locating it using a template. We have an orientation, in this case of 0, covering 100% of the parts in one area. That's the ply thickness, that's the ply density based upon the cloth selected. It's done that for everything all the way down through. And then some of the other things, we put our skin in, our pill ply, which we selected from the 3D interface. We selected a nylon bag. Our debulk interval we set to 4. Our level of mechanization and so on are all set by the rules that we selected when we selected the environment that we did. So I'll move this back. So the top half is user inputs, the bottom half is model outputs, and we can look at things here. So we can look at the operational analysis, work element contribution. So you can see where the cost resides within this part. So as you can see, most of it, autoclave is coming in expensive, the hand layup, finishing, trimming. So maybe we could do something about the autoclave loading up that, operator attendance. We can't change the cure cycle, but there are things we can look at to try and reduce costs to make things better for the organization. We come to this one, then we look at the operational analysis. So our debulking time, our ply placement, setup, roll krill change times is tool prep, inspection delay, and so on. So here again, great information for the cost engineer to have a look at and say, oh, if only we could lay 6 plies at a time, reduce the debulk interval, ply placement, you know, all this sorts of level of mechanization. Can we improve things? And that's what SEER is giving you, good management information. It's not based on emotion, it's based on fact. We have the quick estimate. Now, the quick estimate is interactive. Interactive in respect, you can right click, quick estimate options, choose the things you want to look at. That then appears here in the list. We can set a reference, click on, give it a name, select, accept the name. So we have a reference, we have an estimate, and we can say, what would be the impact of making this every 5th ply? Will we get the savings we're looking at? Heck, yes, 11% saving here. Total minutes down by 7%. How can we achieve this? What can we make better? Can we change the design some way that we can make things better and enable us to do it? So this is the sorts of things you have. We have autoclave operations. It's brought in all the information relating to the part size, number of stiffeners, the cycle. Just drag that down so we can see it better. Information about the size of the autoclave, the loading percentages, operator attendance, cost of nitrogen, energy, mechanization, and utilization. So all of this goes together to give us our cycle times for autoclave, and then this is our trimming. It's calculated trim lengths. We told it we were going to do 5-axis based upon the rules. We're doing some NDT testing here. Inspection, part marking, packaging, and then the finishing itself is the process specific, which is the hand power tools, a little bit of sanding, cleaning, masking, and spraying. And you can control that within the environment when you do it. So that comes together to give us our all-encompassing estimate. We have the aero details report, which is worth highlighting. So for anything that comes in with aero, which we're using in this solution, you get this granularity of cost. Where am I consuming my times, our T1 times, our estimated times, information relating to the autoclave, the trimming. These are not aero operations, so that wouldn't be available there. But you can see quite quickly the information that we want to look at in detail. Reporting, detailed analysis. We can look at all of the operations, the sequences, where the time's being consumed, etc. All of the reports can be exported to PDF. We can export all the information using a feature we call flexible export, which is available in all of the SEER solutions, where we can build and create our own custom templates to take information out, whether it be to a report, whether it be to a file, or whether it be to the notepad for pasting into something else like Excel for turning into other reports and information for management. So that's SEER for Composites. I'll just go back, quick recap. So we import the file, we select the environment and the process group, tell it how many we're going to make, verify this is what we want to do, look at the information relating to the material. This comes in automatically based upon the material. We can adjust the plies based upon our experience and looking at what we have from here. We can add additional plies, our process options, how we're going to cut it, how we're going to locate it, debulking, hot ply debulking, our infusion methods, our trimming methods, whether we want to include or exclude any of these additional items. Click on estimate. We end up with an estimate back in SEER MFG, which we can now save to the database for version control, for permissions, for workflow, and historical reasons. So thank you very much for your time. I'll pass you back to Steve just to conclude.
Thank you, Keith. As we said at the beginning, the intent today was to give you an overview of the general capabilities of SEER 3D and SEER for manufacturing for composite components. I hope we've done that. As I said, we've touched on a number of areas that will be covered in more detail in later episodes, if you will, of these series of recordings that we're doing for our customer base and our prospects and anybody interested. If you have any questions, my details and Keith's details are on the screen in front of you. please feel free to contact us, and we will be more than happy to help where we can. Thank you very much for your time, and hopefully we'll speak to you soon.
Thank you, Steve.